Hey everyone, I wanted to shed some light on the exercise that I've asked you to take a look at at the end of chapter 16. I think I asked you to look at 16.1. I'm not too worried about question A. That's really not that important. But I would like to go through a couple things that are related back to question B. I'm not going to answer the question like exactly as they've asked it, but I'll go through a couple of things that will show you how we can do some time series analysis. Now, I did post an earlier video, one that I had done in Excel, that shows you several different ways of doing time series analysis and how we have to kind of look at trends that are emerging, and also how we can look at seasonality in a data set so that we can account for that seasonality when we're making trends. And if you look at that video, you'll see that trending can be difficult. It's easy if everything looks the same. If all you have to do is take the mean of all of the different time points, it's a piece of cake, right? But rarely is life like that. And hopefully we don't want it to be like that in many cases. We want it to be, sales trending up. There may be seasonality in trends that are needing to be accounted for. So look at that quick first video. Again, like I said, there's some gibberish at the end that talks about the first assignments and this, that, and the other, because the video in truth was made for another class. But because it has good content that's related back to what you're doing this week, I wanted to just go ahead and share that with you. What I'm going to go through in this video is I'm going to go through a script that does a little bit of work with trending, with time series analysis. And we're looking at a file, and this is a file that they want you to pull out from 16.1, and that's the 9/11 travel file. And first things first, though, we have to go ahead and set up our appropriate library. The library we're going to use is Forecast. And Forecast allows us to do things like TS and LMTS and stuff like that, so it contains those functions. But if you haven't installed it, go ahead and install it using install packages. But once you have, go ahead and click on library and bring it up. Okay. And then the next thing I'm going to do is, and it gives you some information about exactly how it's being used and how it was set up. The next thing I'm going to do is I'm going to load up that file, and I'm going to use file choose like I always did. This will do read CSV, and I'm going to drop it into a data frame called travel.df. And it's called September 11th travel _0 or _1.csv, depends on how you downloaded it. And once I've loaded that, I've got that all ready to go. You can do a view on it if you want to see what's in it, but it's basically only 4 columns. The first column is month and year, and the second column is a measure of airline travel. The third column is a measure of rail travel, and the fourth column is a measure of the number of miles traveled in billions. I don't know where they got this information. I think they talk a little bit about it in the book, but it's kind of irrelevant for what we're going to do. Okay, so once we've got the library forecast loaded and we've got the file loaded, the next thing we're going to do is we're going to take a look at some trends. But what it asks us to do is it asks us to look at trends before 9/11. And if you've read through the book, you've got an idea of how you can actually set up a trend analysis for a specific range of dates, assuming that the dates, of course, are set up correctly. So since we have 3 columns, one is date, the other 3 columns, air, rail, and I just call the third one VMT, but it's really cars. What we're going to do is we're going to take a look at a time series. When we do the time series, we have to feed it really 4 pieces of information, 4 critical pieces of information. The first thing we're going to feed it is we're going to feed it the actual name of the variable. And the name of the variable that we're going to feed it is air.rpm. This might be a good time to actually do a view of this data set. That would be view of. And you see that we have air.rpm at the top here of the second column. For the rail column, we have rail.pm, and for the car column, we have vehicle miles traveled in billions, and that's showing here. So that's what I'm going to do over here in this script, this part of the script. I'm going to create a time series. I'm going to call the first one air.ts. That's just a variable that I created, that I pulled out of the air, if you will. And I'm going to set that equal to the time series of travel.df, which is my data frame, okay, with the variable air.rpm, which is this variable here. So I'm just looking at this column, okay. I'm going to start at, and I've created a vector here. Remember, we always use a little c to create the vector, and I'm going to create a vector that's going to give me my year and my month. And my year and my month is 1991. And why did I pick that? I picked that because that's the first year for which we have data. It's the first month for which we have data. So I set up start equals the vector of c, well, the vector basically, which is, of course, with the c, 1990, 1. And then I set up my end. And my end is very specific because I want to do it the last month that we have data before 9/11. So I'm going to go ahead and set that up. And that will be for 2001-8, so August of 2001. And my frequency is equal to 12 because I have 12 measures in a year. So that's all set up. Okay. Then I'm going to do a similar time series analysis for rail. I copied the air one and just changed a couple things. I changed the variable that I'm going to call it to rail.ts, and then I set that equal to a time series analysis of that second column. So rail.pm instead of air.rpm. The same start and the same end date and the same frequency. That's all the same. That's why it's easy to just copy and paste. And then vehicle miles traveled.ps is what I created for the third variable. And it basically did the same thing, but just changed that vehicle miles traveled underscore billions variable there. And when I run those, I can get those time series analysis files. Doop, doop, and doop. I can get rid of this. Okay, what do they look like? Well, let's take a look. We're going to go ahead and plot these, but what we're going to do is we're going to use this parameter for the number of rows that we're actually put into the plot, and we set it as a vector, and it's going to be 3 rows and 1 column. So you'll see what that does in the plot, which is actually kind of cool because we can see all 3 of the plots kind of side by side. We're going to plot air.ts, which is what we created up here. Okay, we'll set an X label and a Y label. Do the same thing with rail.ts, plot rail.ts with an X label and a Y label. And then we'll plot vmt.ts, X label, and a Y label. The Y label is a little different because we're looking at miles and billions. So we've run the time series analysis. Let's go ahead and set up our parameter. It opens up a graphic for us, which we're going to put over here. And go back to our plots. First plot is going to be at the top, and there it is. Second plot is in the middle, there it is. And the third plot is at the bottom, there it is. And that's what that vector does for us. It says we can have 3 rows in our plot, but only 1 column. And we have our appropriate sort of, these are in E notation, and we'll live with that, that's all right. This is what it looked like from the beginning of 1990 all the way to August of 2001. And for air travel, it looked like the number of passengers was going up on a fairly steady trend. Now, it's important to notice in the air travel one, it's important to notice actually in all 3 of them, that you not only have trending, actually, well, yeah, you have trending, but you also have seasonality. And with seasonality, what I mean by seasonality is that it doesn't necessarily equate to seasons like fall, winter, spring, and summer, but there's just general sort of cycles in the data. And it shows, probably if we drilled into this, it shows that the amount of air travel drops in the winter, fall and winter, and hikes or peaks in the summer. And that's looking like, if we look all the way over to the end on the right there, we're in August, right? So it looks like that summer peak keeps going higher and higher each time. So not only do we have seasonality, but we have trending. And the trending means that it's going up, right? It looks like it is going up. Might be a little flat at the beginning back in 1990, 92, 94, but it is trending upward. For the number of rail passengers, that looks like it's trending down. It may be trending down in a pattern that's not as linear as the air travel. And there's a seasonality built into that too, right? So we can see those seasonal spikes, those seasonal lulls. And then for the auto, or the vehicle miles traveled, this one looks a little bit more like the air. It's trending up and is definite seasonality. I would presume that, again, just like air, the travel in the summer is the peak, and the travel in the winter, where you've got the valleys, that's probably represented there. All right. So what we wanted to do, though, and the question that the book is really asking us is, now that we know where that was going up until 9/11, what happened after 9/11? Go ahead and close out these plots because we've kind of gotten the information that we needed out of those. Okay. So we're going to include the 9/11 trends, and what we're going to do is we're going to rebuild, or we're going to build actually new time series. What I've done is, instead of air.ts, rail.ts, and vmt.ts, I just added a 9/11 there for some new notation. But basically, the time series looks very similar, except my end date. My end date goes all the way to the end of the file. This data file that I'm using terminates out at April of 2004. So that's the only change I made, is to terminate out at April 2004. And I'm just plotting the entire data file. So it starts January of 1990 and ends April of 2004. So I'll go ahead and build those time series. Done, done, and done. And now we can go ahead and plot those out. Okay, we're going to set up our parameters. And now we can go back to our script. Let's move that over here so we can see what it's doing. There's our plot, and our plot. Okay, so let's ignore the air one for now, because clearly that one was impacted by 9/11. The rail one doesn't seem to be, and neither does the car one. So it seems like the car and rail, really not that much. But air took a big hit. I mean, not only did it take a big hit, but it set it back. The peak that we had in August of 2001 was looking like it was going to be one of the bigger peaks. Probably if nothing had happened, September of 2001 would have been even bigger, and we would have just continued the growth upward. But what it did is not only did it drop suddenly in that period of time, but it never really recovered. It never really recovered up to 2004. I mean, probably right around here or right around here, it's getting closer to where it was. But the ridership on the airlines dropped, and that was an impact of 9/11. So that's kind of what the script is telling us, what script is asking us to do. So what we're going to do now is we're going to take a look at, okay, let's take a look at trends and seasonality. If we were to predict this, what would it look like? So there's a way that we can do this. We can do this using something called time series linear modeling. And this is very similar to when we were doing linear modeling in last quarter. We were doing regression. We were using the linear modeling function. And time series linear modeling allows us to do that over a time series now, right? It's not just random. There's an actual order for it. So we'll go ahead and we'll create a couple of linear models, 3 linear models. We'll have air, rail, and VMT. The air linear model is going to be created using the time series linear model. We're going to use the 911 TS that we created up here, actually up here. So that's our time series. And what that allows us to do is go across that time series, and then we're also going to account for what is the trend, the trend upward, and can we account for seasonality. This is beginning to get us to a place where we can then predict into the future, about next week in next chapter, where we can predict into the future what our numbers are going to be like going forward. And this is again getting into sort of predictive analytics. But once we can get an understanding of how over time, when we account for the trend and we account for the seasonality, how close are we when we make our projections? Again, remember, when we do a predictive model, we always go back and look at old data and build our predictive model based on old data. So that's what we're doing here. Is we're going to take a look at what did we see in the air, in the rail, and then the vehicle miles traveled. What did we see when we ran that as a linear model, and how does that compare, once we account for trend and seasonality, how does that compare to what actually happened? Let's go ahead and build those. Sets those up, okay, and now we can replot those. And what we're going to do is we're going to plot, not only are we going to plot the time series with the appropriate labels, but we're also going to plot a line, and a line is going to be fitted to what we built when we did air.lm. Remember, we did air.lm up here. It gave us a line, a predictive line that accounts for the trend and the season. Okay, and so for each of the plots, we're going to plot that line, and it's going to be a fitted line. This LWD is which of the plots is it going to be plotted against. So we have 1, 2, and 3. And then what color did you use? The first one I did blue, the second one I did red, the third one I did green. And that just offsets the predicted or projected line against the actuals. So we can see just how close it is when it's able to account for trend and it's able to account for seasonality. Okay, there's our plot. Here's our first one. We plot it. Looks kind of like what we were expecting. Okay, and then what we're going to do now is we're going to say, okay, based on that, what would the system have predicted or have projected? And what it would have projected is, it's very interesting because it basically takes all of the data that it has and it does a pretty good job of predicting or projecting kind of past data, especially way in the past. But when we get hit with the 9/11 thing, it doesn't really know how to account for that because that was such an anomaly. And so our actuals dropped way, way, way down. And then the actuals that followed on kind of dropped down as well. So the model itself sort of accommodates the majority. It accommodates these lines here. It does a pretty good job of accommodating these, but isn't really able to deal with that anomaly of where it dropped so much. It does actually accept kind of that it was there and sort of accounts for it. But of course, being that it was so anomalous and it was, kind of a short-term period, you'll see that that's the only time when the blue line, the predicted blue line, actually separates from the actual line. Take a look at the next one. The next one is going to be how much was the rail traffic impacted. So there's our plot, and there is our red line. It does a pretty good job based on all the past information. It does a pretty good job of being able to sort of account for seasonality and pretty good job of being able to account for the trend. There's a couple spots here in late 90s and the late 90s basically to 2099 where the rail dropped substantially, and it wasn't able to account for that. The model doesn't really account for that. So the model just basically is going to take everything it can and make its best guess. And remember what I've told you, anytime you build a model, the model is going to be off. But if this is in fact over the course of 14 years, it's this close to the actuals, then if we want to go project from 2004 to 2019, or if we had the data, project from 2019 out to 2026, we might be able to have a fairly good level of confidence that the model is going to be able to predict something that we can believe in. Go to the next one, which is vehicle miles traveled. That is steadily increased. And the model does a great job of predicting that because it is very consistent, very consistent. See, these models here are not as consistent, especially the rail one, but the vehicle miles traveled is very consistent and very seasonal and very solid trend. So the model is able to do a really good job of predicting what it is that we actually had. So the model and the actual are not very far apart. This is all getting set up for next week. What we're going to do is we're going to continue with trend time series analysis because it's important. I think it's important and a useful tool. And we're going to start using time series analysis as a predictive method or a predictive tool. What I'd like you to do, though, is I'd like you to go ahead and take my script if you want, duplicate it, get the practice of being able to put that together. You can watch the video, slow the video down, stop the video, however, to see what I've put into the script. I would love it if you would do interesting things with the script. Change the colors, change the way it's plotted, whatever you want to do. But yeah, this will be kind of for your assignment for Module 2. Okay, let me know if you have any questions.